Welcome in the last section of our algorithms course. In this section we'll be looking at the graph algorithms and data structure that is behind that graph algorithms. We will see how to represent a graph and we will construct a graph in Java programming language. Next we'll implement algorithm to search and traverse our graph using breadth-first search algorithm. Then we will see different algorithm for searching, that is a depth-first search. So let's answer a question of how to represent a graph. We will see how to represent a graph and what the edge is and vertex. At the end, we will create a graph in Java programming language. So graph is data structure that models the relationships between points. Here we have graph with 5 vertices A, B, C, D and E and more edges that are joining two vertices. So we have edge between vertex A and E, as we can see. Also we have edge between vertex E and D. Also we can see that there is a vertex between DC and CB, and so on and so on. So we can see that we can traverse from any vertex to any other using edges. And here we have more detailed example, so we have more vertex and some more edges that are joining two vertices. And let's answer a question, who uses graph? So that graph and everything related to graph processing is used very often in social networks. For example, on Facebook, you and your friends can be modeled as graph. So you are a vertex and other friend is vertex and your friendship is edge between those vertices. And you can go to other person and Facebook can suggest you that maybe you know that person because there is a lot of edges pointing to other person that also has connection to that person that Facebook is recommending to you. We will create a graph using adjacency list. So this is a representation of graph that uses list of arrays or arrays of arrays. So here we have graph with 5 vertices, 0, 1, 2, 3 and 4. And we can see that each vertex has own cell in array. So if we want to get all edges to other vertices for vertex 0, we need to go to the index 0 of that input array, and then on that index there will be list of vertices and edges from that 0 to other vertex. So there is a connection, an edge between vertex 0 and 1, so in that adjacency list for a vertex 0 there is a record 1. There is also a record 2, 3 and 4 because there is connection from 0 to any other vertex. But on the other hand, from vertex number 1 there are only connection to 0 and 3, and we can see that in that adjacency list that this situation is modeled. So we'll be using that technique to create graph. We will create a graph class that has one property, that is number of vertices. We need to pass that number explicitly in constructor to know how big the adjacency list should be. Then we have that adjacency list representation, and that is actually array of lists. So if we will want to take all edges to other vertices for vertex 0, we will do adjacency of index 0. And it will return a linked list, and then we can do some operations on that vertices that are connected to that specific vertex. Then we have a constructor to which we need to pass the number of vertices. We are initializing our property and we are initializing the adjacency list to linked list of that size. Then for every vertex we are iterating and we are initializing to the new linked list. So we want to initialize every vertex to have adjacency list that is yet empty. Then the most important thing when building a graph, we want to have a method that adds an edge between 2 points. So this is a method addEdge when we are passing source vertex and destination vertex. And to add it, we just simply taking the adjacency list for the source vertex and adding it to the adjacency list for it, that destination vertex. And that way we are able to construct a graph.